Hello. The last two episodes, we have gone through the overview of Indian oil and gas industry as well the Indian refining industry. Today, we are going to focus on the raw material for the refining industry and petrochemical industry. What are they? They are nothing but crude oil and natural gas. We will try to understand how crude oil and natural gas are produced from the Mother Earth. So, this is going to be our third module. In this module, we will try to understand more about crude oil, natural gas, and how they are obtained. So, specifically, the three major steps: exploration, drilling, and production, which is part of the upstream segment of the value chain, which will supply the material to the downstream, that is the refining and petrochemical segment. Now let's try to understand how the crude oil is formed and where it is located. Petroleum or crude oil is formed million years ago by the decomposition of vegetation and marine organisms. And these petroleum fractions are trapped in between several layers of rocks, primarily between the impermeable rock and the reservoir rock. So the oil is available in the reservoir rock, and only when you start puncturing the different layers, you will be able to expose the oil which can come to the ground surface. Long time back, the petroleum was seeping through the rocks and it was visibly seen on the surface of the earth. And this is how the hydrocarbons were identified. And this was much of the petroleum discovered during the 19th century was from observation of the seeps. But after some time, the naturally occurring seepages were all exhausted and identified. So, this is where there is a need to proactively go and locate the oil and then drill for oil. So, this is the drilling, exploration, and production is a complex process involving multiple stakeholders and multiple steps. Now, let's try to understand these steps at a very high level. The very first step is to go for the licensing and agreement. This is the very first step of exploration of oil. The exploring companies, or which are called upstream companies, they need to enter into a contract with the government in a particular country. Most of the time, the Ministry of Petroleum in the respective countries, they will be the nodal agency who will be entering into contract with the exploring company. And there are two types of contracts for the exploring companies. One is simple license to explore and produce oil, wherein they have to just pay the license fees, royalty, and taxes. The second case, they have to get into a production sharing contract where the state owned company is also made as a partner. So, this is more like a joint venture kind of operation. Throughout the world, most of the companies operate in these kind of agreements. Now, let's try to understand what are all the different kind of techniques involved in the exploring oil. So, as I said earlier, the oil exploration was identified by visually seeing the seepages, but once the seepages are all identified and exhausted, now there is a need to proactively identify, explore, and then we have to start drilling. There are three major techniques available for the upstream companies to do the exploration. Number one is geological way of doing it. Number two is geophysical way of doing it. And third one is geochemical way of doing it. Let's try to understand each one of them. In the geological surveys, the geologists develop a map where hydrocarbon might occur based on wide variety of geological information. And where do they get this information? So, these information primarily are obtained through an aerial survey or an airborne survey or a satellite survey. What are the kind of information we try to obtain from the aerial survey or airborne survey? Let's see. Aerial surveys are carried out by aircrafts or helicopter flying approximately 300 meters above the ground level. And primarily it covers pictures of the landscape, including civic location, water bodies, monuments, places of geological importance. Also, readings of the Earth's magnetic and gravity signals are covered in this aerial survey. So, this is the very first step where we try to get a picture of Earth's surface and we are trying to identify the oil occurring bodies. And once we come to know about places of importance, then we will be able to identify whether it makes sense to do the drilling activity there or not. The next kind of survey is satellite survey. Satellite surveys are better than aerial survey, and this gives accurate satellitary imagery, and this is one of the most cost effective methods of exploration. Remote sensing from spaceborne has long been used in the hydrocarbon industry to map the surface geology, topography, and hydrocarbon seepage. The last decade, rapid advances in satellite systems, unmanned autonomous vehicles, that is UAVs, sensors, and the scales of survey have further expanded the application in the oil and gas exploration with the help of satellite technology. Now we move on to the geophysical surveys. Geophysical surveys are again broadly classified into three major techniques. Number one is magnetic survey, where we are trying to determine the strength of Earth's magnetic fields at a specific location. The second technique is gravity survey, where we try to determine the strength of Earth's gravity at a location. The third one is seismic survey. We are trying to draw the subsurface maps using sound waves. Magnetic surveys. Magnetic surveys are a geophysical method to image anomalies in the Earth's magnetic field caused by source bodies within the subsurface. So, as I said earlier, the oil is trapped between different kind of rocks. That is, it is in between the impermeable rock and the sedimentary rock, and it is available in the reservoir rock. Each of these rocks have different kind of properties, and through magnetic survey and other kind of techniques, we are able to figure out what kind of rocks are available at different depths. And once we go through these surveys, we will be able to figure out whether reservoir rocks are available at a particular location or not, and that will give us some kind of insight whether to do the further drilling process. And magnetics are commonly used as a low cost way to understand the structure of the subsurface during the beginning phase of exploration. So generally, magnetic survey, to start with, we do this kind of survey which will give a high level picture of whether oil bearing rocks are available or not. Then the next one is a gravity survey. Gravity survey passively measures natural variations in the Earth's gravity over a map area and then try to relate these variations to geology features in the subsurface. A gravimeter is an instrument used to measure gravitational acceleration. So it is basically a portable instrument, so which are taken by the geologists to different locations, and then they try to measure the acceleration due to gravity. A gravity survey is an indirect means of calculating the density property of subsurface materials. The higher the gravity values, the denser the rock beneath. So both magnetic survey and gravity survey gives a kind of indication what kind of rocks are present under the subsurface of the Earth. So in the seismic survey, it is a low impact, non-invasive method of gathering information about the location and characteristics of geological structure beneath the Earth's surface. This information is used to produce maps of structures identifying areas where oil and gas deposits are found. So primarily here, with the help of the specific instrument, the sound waves are produced and sent at the subsurface of the Earth. Based on the time taken for the sound waves, we are able to figure out what kind of rocks are present. This technique is based on determining the time interval that elapses between the initiation of the seismic wave at a selected short point that is the location where the explosion generates seismic waves, the arrival of the reflected or refracted impulses at one or more seismic detectors. So, this seismic survey can happen either in land or in sea. So, only the different kind of instruments are used, but the basic principle of operation is going to be the same. Once we have enough information from these kind of surveys, whether through magnetic survey or gravity survey or seismic survey, then the geologists they try to process the information and to do some kind of interpretation of the data. The seismic interpretation is the science and art of inferring what lies underground at any given area based on the seismic data provided. In using this method, the geologist must use their understanding of the collected data to infer the most likely interpretation out of the different possibilities. So, this is where the data is converted into information, and based on the information, the decision making process is happening. So, this is where the data is playing a crucial role. So, of course, all the data obtained from the subsurface may not be of good quality. So, data cleaning and the data processing, they are all essential steps before we do the data interpretation. After doing the interpretation of the data, now we come to understand whether a particular area has got enough potential for oil. So, once such an idea is formed, then the exploratory wells are dug. Exploratory well is to confirm the existence of oil or gas in a basin identified through geological and geophysical surveys. So, this is almost like you all might have seen how a bore well is dug in our civic location. The same concept is used, but definitely we are going to use a different set of equipments, and of course, safety aspects are being taken care because crude oil, natural gas, both are hydrocarbons which are flammable in nature and they are also explosive if not properly handled. The very first exploratory well drilled in a field is called Wildcat Well. The very first successful well showing hydrocarbon is known as Discovery Well. Suppose if oil or gas is not present in an exploratory well, they may be abandoned and then the upstream companies will move on to their different location and then they will start drilling the additional wells. Now, after identifying the oil potential after doing the exploratory well, now we have to go ahead with the full-fledged drilling operations. Again, these full-fledged drilling operations can happen in land or sea. If it is happening in land, it is known as onshore drilling operations. If it is happening in sea, it is known as offshore drilling operations. To perform this drilling, we use a complex set of equipments known as drilling rig. Drilling is a continuous effort in a field even after discovery and the production of hydrocarbon. The massive structure of equipment used for drilling is known as drilling rig. If you see the picture, it has got multiple components and systems. For example, it has got a mud circulation system, the drilling pipes, the drill bits, and then Kelly. There are so many components involved in it, and it is a very tall structure through which we will be able to effortlessly do drilling to several thousand meters of oil well. Drilling a well may take several days to months, depending on the location and the availability of hydrocarbons. So, once oil is obtained, now we are moving into the production phase. Primary production phase, 25 to 30% of the oil in the reservoir can be recovered by the natural reservoir drive. What does it mean? Actually, all this hydrocarbon, whether it is oil or gas, they are trapped inside the reservoir rock which are formed million years ago. And they are under constant temperature and pressure. So, the moment you start drilling that particular rock, the oil and gas will start coming out on its own pressure. So, this way, almost to 25 to 30% of the oil is taken without any additional driving force. But once this started declining, we have to put up additional mechanism to take out the oil. For this, one important equipment used is the sucker rod pump. The popular method used for low pressure shallow well is sucker rod pump to pump out the oil. This is also known as a nodding donkey. So primarily here the circulatory motion of a motor is converted into a vertical longitudinal movement through which the oil is taken out from the oil well. So even after you employ the sucker rod pump, after some time the oil production will start declining. At this point of time, the production companies will start employing multiple other techniques which are bucketed under enhanced oil recovery, or in short called EOR. What are the techniques? Number one is water injection, number two is steam injection, third one is in situ combustion. So here in the water injection method, just a few meters away from this production well, a pipe is inserted and high pressure water is injected inside the soil. So this high pressure water will start driving the oil and it will exert a pressure, and the oil will move towards the bottom of the drill pipe, and then it will help the oil and gas to come out. So this is known as water injection. The second technique, steam injection, instead of water we are now allowing high pressure steam. This is employed where you come across highly viscous oil. This highly viscous oil is getting diluted by admitting the steam. The steam is melting the oil, and the viscosity of the crude oil is reduced, and that helps the pumpability from the bottom of the earth to the upper surface. The third technique, in situ combustion. So here the oxygen is sent inside the oil well, and then it is allowed to form a combustion, and the combustion products exert pressure for a specific interval of time, and after that water is injected. So this oxygen and water are alternatively sent inside the oil well, and that will be the combustion products will be the driving force for the oil to move from the bottom of the earth to the upper surface of the earth. So these are all some of the enhanced oil recovery techniques. Now once oil is producing, the upstream companies will start developing the field. This phase is known as field development phase. When results of exploratory well indicates the possibility of viable oil or gas find, a field development plan is created. So this has got multiple steps. The plan contains details such as projected production profile, pressure, temperature and well production data, recovery techniques, life of the field, enhanced oil recovery methods, facilities required to develop, environmental impact. So all these things are taken care, and accordingly the infrastructure is being developed. Now you are already explored and you have drilled the oil well, and now you are able to produce economic quantity of oil and gas. The last step is the oil field processing. What do we do? So as I said, once you start drilling, you will not only get oil, you will also get gas and water. These things need to be separated and processed. So this is happening as a 5-step process. The very first step, oil, gas, water, they are separated. Then the crude is stabilized. To understand more, I will cover that in the next subsequent slides. Then the third step is the removal of water from crude oil, which is known as crude dehydration. Similarly, water is removed from the natural gas, which is known as gas dehydration. Finally, the gas is sweetened, which means the impurities are removed. In the very first step, once the oil is obtained at the surface of the earth, the oil, gas, water, they need to be separated. So this separation is happening in a equipment known as separator, which are having some internal to facilitate the separation. Gas being the lightest product that emerge from the top of the vessel, water being the heaviest among the three, it will settle down at the bottom of the vessel and it is continuously being drained out. Then oil will be floating on the surface of the water, and it will also be continuously be taken out. So this is how the three-phase separation of oil, gas, water is happening. The next step is crude stabilization. Crude oil is basically a mixture of several hydrocarbons starting from methane, ethane, propane, pentane, hexane, and even it moves on to the heaviest asphaltic hydrocarbons. So they are all available in the form of a liquid inside the earth, but the moment they are taken out and they are depressurized, the gases tend to come out. So it is not safe to crude oil as it is in atmospheric pressure. We need to separate the lighter hydrocarbons and we need to separate the slightly heavier hydrocarbons. This is what being done in this particular phase known as crude stabilization. In the crude stabilization phase, we use different kind of separators at different operating at different pressures. For example, we have high pressure separator, HP separator, then medium pressure separator, and finally low pressure separator. So in every stage of this activity, the lighter hydrocarbons are separated out, and then the crude oil as a liquid hydrocarbon is finally taken out, which is ready to be taken for the downstream processing facilities known as refineries. Finally, the water needs to be removed from the crude oil. Reason number one is water is a corrosive substance which can corrode the pipelines and other equipments, number one. Number two is the end customer is not going to pay money for water. Number three is unnecessarily transporting water will also incur cost on logistics. So it makes sense to remove the water in the upstream facility to the maximum possible. So this is happening in this particular phase where we are trying to heat the crude oil and we are also trying to employ a electric grid. With the help of the electric grid, the separated water from the crude oil is coalesced and then finally it is drained off. So the water-free crude oil is now stored in storage tanks and then they are taken to refineries through pipelines or marine tankers. As I said, not only crude oil, natural gas is also a raw material that is coming from the subsurface of the earth, which are taken to the downstream processing facility as a raw material. This gas will also have lot of moisture. Again, the moisture, it is going to corrode all the equipment and this has to be removed. There are different techniques used for dehydrating or the removal of moisture from the gas. One of the techniques uses silica gel or molecular sieve for water removal. The other technique is to use the different kind of chemicals known as glycols. Either triethylene glycol or ethylene glycol is widely used for absorbing the moisture from the natural gas and then the moisture-free gas is taken to the processing center. After dehydration, the gas needs to be sweetened. What does it mean? The gas has got lot of unwanted or corrosive chemicals which are going to be harmful in the downstream processing facilities. So the primary substance that is not desirable is the hydrogen sulfide and then carbon dioxide. So these two gases need to be removed before we send or sell the gas for the downstream facilities. So this is happening by employing the amine treating process and the sour gases which are having the sulfur bearing compounds that will be treated. All the gases or all the crude oil will not have sulfur bearing compounds. The sulfur bearing crude or gas will happen based on the geography where their oil wells are dug. Depending on the location, the gas sweetening facilities would be set up. So right now we have just covered about what is happening at offshore facility, that is land-based drilling, production and processing. So the same kind of activities can happen in sea, which is known as offshore production facility. The basic processing requirements and schemes are very much similar to onshore processing for the offshore production. However, in certain areas, the configuration and the design of offshore facilities may differ. Floating production, storage and offloading, in short known as FPSO, is typically used in offshore drilling. FPSO is generally a large tanker or a vessel with production and storage facility. It is a comprehensive setup where the oil, gas, water, everything is produced, separated, and then finally ready for transportation. Now we have already understood how oil and gas they are produced, they are separated from the mother earth. Now these oil and gas need to be transported to the downstream processing facility. This can happen through three different modes. Number one is pipeline transport system. Second one is marine tankers or barges. Third one is road and railway tankers. Pipeline is used for transportation of crude oil and natural gas to the processing facilities. For bulk movement, it is the most economic way of transportation. Pipelines range from short distance pipeline to cross country pipelines. And of course, the pipeline's integrity need to be always monitored. That means the pipeline should not corrode and give way off, which may result into the leakage or explosion. So constantly monitoring the health of pipeline is an important activity when we try to employ the pipeline transport. The second popular mechanism of movement of hydrocarbons, whether it is crude oil or gas, is through marine tanker transport. Marine tankers are large vessels used for bulk supply across sea, where for some reason the transport by pipeline is either not economical or technically or politically not possible. The supply of the cargo by marine tanker is not continuous, it is actually a batch process. But definitely, this is the second most popular way of transporting crude oil or natural gas after the pipeline transport. The third one is through road and railway tanker transport. Road and railway tanker transport are primarily used for moving the refined products or finished goods from the refinery. But there are places where crude oil can also be transported through road and railway tanker transport. Of course, this is not a cost effective method, but still being employed in select locations. So, in this episode, primarily we try to understand what are all the raw materials for the petroleum refining industry, that is crude oil and natural gas, and it is our responsibility to understand how this crude oil and natural gas are being produced. So, in that context, we try to understand the different techniques like exploration, drilling, and production. These steps involve multiple stakeholders and multiple steps. This is what we have tried to understand, and we got a high level overview of the raw material meant for our own petroleum refining industry. Now we'll get to know more about petroleum refining in the next coming episodes. Thank you so much.